So 7-1 is finally about trig. We are going to start out with right triangle trig, which many Algebra 2 teachers or geometry teachers touch upon. And then we're going to use this information to build past angles that are stuck in a triangle. In a triangle, we're stuck between things between 0 and 180, not really 0 and 180, but you know what I mean. So we have limitations within a triangle. So we're going to learn how trig falls in a triangle, and then we're going to bring that out of the triangle, and we're going to look at all of the angle possibilities. So first, let's take a look at a right triangle. There's some things you need to know. This right here, that symbol, is the Greek letter theta. It is customary in a math class to use a Greek letter for our angle measures. So you will see me use theta, you will see me use sometimes alpha, you will see me use beta. Those are just pretty common Greek letters. And if I use any other Greek letters for an angle measure, I'll let you know what that Greek letter stands for. But theta is the most common. It's just like a variable x, y, z. It just happens to be Greek letters are used very commonly for our angle measures. So keep that in mind. Now, there are 6 trig functions that we're going to be dealing with. And the ones that you see here are the most common. You probably dealt with those in either Algebra 2 or geometry class. This is the abbreviation for the word sine. Don't say sin. That's not what it is. It is the word sine. That is just an abbreviation. So this is the sine of angle theta. So that we are looking at whatever the sign is, which we'll talk about in a second, in relationship to where theta is sitting. If theta was up here, it'd be a different ball game. So where that theta is sitting, what is the sign? This is the abbreviation for cosine. Don't say cos. Don't say anything like that. That is the word cosine, and that is just its abbreviation. Don't say tan. That is a tangent. That is the abbreviation for a tangent. Now, what you want to get in your head and what you want to memorize, a silly little saying, but it's very helpful, is so ka toa. Okay. Now that's just, think of it as, I don't know, the math Indian name. I don't know. It's a name of some sort. And Sokotoa is just a little way for us to memorize the 3 trig functions. Let's start with this one. What is the sine of theta? The sine of theta, the O stands for opposite, the H stands for hypotenuse. Let's take a look at our right triangle. Where the angle is sitting, if we look at the leg that is across from it, that is our opposite leg. If we look at the leg that is attached to it, that is our adjacent leg. And then the hypotenuse is always our longest side. We've done hypotenuse in the Pythagorean theorem. That is always the one across from the 90. So let me say that again. Wherever theta is sitting, the leg across from it is our opposite. The leg attached to it is your adjacent. The side across from your 90-degree angle is your hypotenuse. So sine is just the relationship in that particular right triangle of the opposite over the hypotenuse. OH, opposite over hypotenuse. Cosine, we relate the adjacent and the hypotenuse. So that's why it's ka, so ka, toa, C-A-H. It is the adjacent over the hypotenuse. And the relationship between the opposite and the adjacent is our tangent. So it relates an angle measure with 2 particular sides of a triangle, a right triangle, where that angle is sitting. The angle will always be one of the acute angles. So it's either going to be down in this corner or in this upper corner. We're never referring to the 90-degree angle in a right triangle. So the sine is the opposite over the hypotenuse relationship, cosine is the adjacent over the hypotenuse, and tangent is the opposite over adjacent. So trig functions are just a way to relate how an angle measure affects the sides of two of the sides of our triangle. Now, you need to memorize the fact that these are the reciprocals. These three here are our reciprocals. A reciprocal is the flip of the thing that we are talking about. CSC is the abbreviation for cosecant. The cosecant and the sine are reciprocals of one another. Since the sine is opposite over hypotenuse, the cosecant then is hypotenuse over opposite. So the CSC abbreviation is what you'll use for cosecant. You need to memorize that the sine and the cosecant are reciprocals of one another. The cosine and the secant are the next pair of reciprocals. Since the cosine is adjacent over hypotenuse, the secant will be hypotenuse over adjacent. Hypotenuse over adjacent. Now, don't be confused by the names. The names are just about the graphs. These two graphs look alike, these two graphs look alike, these two graphs look alike, but they don't refer to who are reciprocals of one another. Sine and cosecant are reciprocals. Cosine and secant are reciprocals. And finally, tangent and cotangent are reciprocals. The abbreviation you want to use for cotangent is COT. Don't say cot. That is cotangent, and it uses the fraction adjacent over opposite. So if you memorize these three facts, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, then just memorize who is a reciprocal of each other, and then you get to flip it upside down. Okay. Now, I will tell you that we will have some memorization quizzes along the way. I'll give you a paper. It'll say sine equals cosine equals blank, and you'll have to say opposite over hypotenuse, and you'll have to fill that out. The key to trig, this stuff mathematically isn't super difficult, but you do have to memorize a lot of new facts. So please, that is something that's really important, that you take the time to memorize the facts. We'll probably even make maybe some flashcards or some ways for us to memorize those facts. Any questions about our first sets of facts there? Okay, so now let's go to our first example. So in example 1, you are given a triangle and you are given two sides of that triangle. You are given the fact that we have our side that comes off of it, our leg that comes off of it is 56, and our hypotenuse is 65. Now let's label those as such. Let's label this with an H, and then let's label that with an A. Now, before we can find the exact values of the 6 trig functions, we have to have all three sides, because tangent uses opposite, and so does the sine. So if we don't have this side, we can't proceed. If you have two sides of a right triangle, can anybody tell me how you find the third side? Yes. Pythagorean theorem. All those facts we learned about triangles in the past continue along with us as we go into trig. So what we know is, let's call this, since this will be our opposite, I'm going to put OPP so it makes a little more sense when we put it in. The sum of the legs squared is equal to the hypotenuse squared. So I know that 56 squared plus our opposite squared should equal 65 squared. It's always equal to the hypotenuse squared. 56 squared is 3,136. 65 squared is 4,225. So our opposite squared is 1089. And so our opposite will just be the square root of that. Now, normally we put that plus or minus symbol, but because of the fact that this is a length of a triangle, for what we are doing, that will always be the positive version. So you don't really need the plus or minus at this point. There are going to come some times later on where we have to make a decision. Do we use positive or negative based upon just some things that we will learn. So it's important that we remember that's there, but we don't really need it in a triangle. So we find that our opposite is 33. Okay. So that should always be your first step. If you see that you don't have 3 sides of the triangle, you got to find all 3, and you want to label them. This is my adjacent, this is my opposite, this is my hypotenuse. Once that is done, over here on the side, I'm going to write the sine of theta, the cosine of theta, and the tangent of theta. Now, I always write those in that order because that is the order that you want to have them memorized. Remember, I told you to memorize that silly little saying, SOHCAHTOA. 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 And because it is in that sine, cosine, tangent order, I always write them sine, cosine, tangent order because then that goes with what I have memorized. Now, sine is opposite over hypotenuse, so that would be 33 over 65. Cosine is adjacent over hypotenuse, so that's going to be 56 over 65. And then finally, tangent is opposite over hypotenuse, or I'm sorry, opposite over adjacent, so that's 33 over 56. Now, none of those fractions reduced. If those fractions reduced, I would want them in reduced fraction form. That's your answers. That's your first 3 trig functions, the sine, the cosine, and the tangent. The next ones I'm going to write in order based upon the reciprocals. So next to the sine, I'm going to write the cosecant, CSC. Next to the cosine, I'm going to write the secant, SEC. And next to the tangent, I'm going to write the cotangent. So I always write them in that order because then it goes with what I had to memorize. I'm consistent and I follow that order every time. It just makes it so that it's easier for me to go through the process. So now just take those fractions, flip them upside down. You got it. So this is 65 over 33 because these two are reciprocals. Cosine and secant are reciprocals, so that's 65 over 56. Tangent and cotangent are reciprocals, so that's 56 over 33. And we have found the exact values of the 6 trig functions related to theta. Now, if theta was in this corner, we would have different values. So always relate it to where your theta is sitting. This is the opposite, this is the adjacent, and this is the hypotenuse. Okay. Do we have any questions about that example? Good? Okay. Okay. So now, I think we still have a few people still writing. Let me give you one more second here. Let's do it again. Now, the only difference between the first example 1 and the second example 1, don't know why they did that, but anyway, the only difference is the fact that this time we are missing a hypotenuse. Now, let's label our sides. Where theta is sitting, this one is opposite. I usually find the opposite first. I don't know. I just do. The leg, the things that make the L, the leg that is attached to it is 16. That's my adjacent. So I am missing my hypotenuse. Now remember, the Pythagorean theorem says that the sum of the legs squared is equal to the hypotenuse squared. So that's why it's important you know what's our hypotenuse. Because I know that 12 squared plus 16 squared should equal my hypotenuse squared. Well, 12 squared is 144. 16 squared is 256. That's 400. So h is going to be 20. Now, again, when we square root, we may have to eventually care about the plus or minus. At this point, it's a side of a triangle. It is a positive value. So now we know our hypotenuse. Okay, so now that you have all the sides labeled and you have the value of all three sides, now you are ready to do our 6 trig functions. Now remember, you have to have memorized SOHCAHTOA. And so I'm going to write sine first, then cosine, then tangent. I always write it in that order because then you're going to memorize it and you're going to use that SOHCAHTOA idea to help you. Okay. Now remember, sine is opposite over hypotenuse. So where our angle is sitting, our opposite is 12. Our hypotenuse is 20. This is 12 over 20. Now the last fractions didn't reduce. These fractions do. Both top and bottom are divisible by 4. Let's divide both top and bottom by 4. We get 3 over 5. Okay, now let's do our cosine. Remember, cosine is adjacent over hypotenuse. The leg attached to it is our adjacent. Our hypotenuse is always the longest side. So this one's going to be 16 over 20, both divisible by 4. Reduce it down. We get 4/5. And then tangent is opposite over adjacent. Opposite is 12. Adjacent is 16. That's why we label our sides. So that's going to be 12 over 16. Both divisible by 4. We get 3 over 4. And many times the relationship of these numerators you will see in the tangent, because sine started out as opposite and cosine started out as adjacent. So now that leads us to our reciprocals. Now again, always write your reciprocals in the same order. This is cosecant. The reciprocal of cosine is secant. The reciprocal of tangent is cotangent. Now, you can flip over the originals, but you already took the time to reduce them. So flip over the one that's easiest and saves you the most time. If you flip over 12 over 20 and get 20 over 12, it reduces to 5 over 3. So why not use these versions? You don't have to. You could write 20 over 12, but what's it have to reduce down to? 5 over 3 anyway. This one will be 5 over 4. This one will be 4 over 3. So I personally would flip the most convenient version, but any version will get you the correct answer. You just might need more work afterwards. Anybody have any questions on that one? Any questions there? Is that making sense so far? Hopefully you did this somewhere along the line, whether it was algebra 2, geometry, somewhere. So hopefully this first few sections will be a little bit review. Okay. Now let's dive into one that's a little different. This one says that the sine of theta is equal to 1/3. Find the exact values of the 5 remaining trig functions for the acute angle theta. They have drawn a triangle, and if your theta isn't in there, could you have your triangle make sure theta is in there, okay? Because where you put the theta is going to determine where you put other things. So I know that the sine of theta is equal to 1/3. Now, the sine is the relationship, remember SOHCAHTOA, of the opposite and the hypotenuse. So let's just label this in our triangle as opposite our angle theta, and this as our hypotenuse. So let's make the triangle fit the situation. So our opposite, we're going to make 1, and our hypotenuse is going to be a 3, right? The opposite they said was 1. The hypotenuse they said was 3, if we know the sign is the fraction 1/3. Now, if we do the same thing we did for the last problems, in the last problems, we used Pythagorean theorem to find the missing side. Well, we're going to do the same thing. Let's label our sides. Remember, we forced this one to be the opposite and this one to be the hypotenuse. So this one's going to be the adjacent, right? So I know that 1 squared plus my adjacent squared should equal 3 squared. That's 9 minus 1, so that's 8. So the square root of 8 is my adjacent. Now, you shouldn't leave at the square root of 8. Hopefully you know by now, since 8 is 4 times 2, that we can write that a little nicer as 2 radical 2. Okay, so now we have all 3 sides. They're all labeled. Now we do it exactly like we did the last problems. Our sine was 1/3. Our cosine is adjacent over hypotenuse, so 2 radical 2 over 3. Our tangent is opposite over adjacent, which is 1 over 2 radical 2. Now, we should rationalize any radicals in our problem that end up in our denominators. So technically, if I multiply by radical 2 on top and bottom, I get radical 2 over 4. Okay, now we need to find the other 3. We're not done. So write down the reciprocals to the side. So that's cosecant is the sine's reciprocal, secant, and tangent. You see I'm pretty consistent every single time, kind of doing the same order, kind of doing the same thing. It'll make the process flow a little nicer. And then let's flip those over. So if I flip over 1/3, I'm going to get 3 over 1, which is just 3. Now, for my secant, if I flip over 2 radical 2 over 3, it becomes 3 over 2 radical 2, but you should rationalize. So it's going to multiply by radical 2 on top and bottom. I get 3 radical 2 over 4. Tangent. Flip the one over that puts the radical in the top. So see, that was what we started with, 1 over 2 radical 2. So make it 2 radical 2 over 1, which is just 2 radical 2. So when you have radicals, sometimes a little work, you gotta do a little bit of work. Now, see how they used the words exact values? And I did not use any buttons on a calculator for this. You might want to, if you weren't good at your squares or square roots, but all in all, you'll notice there's no buttons I needed to push. I didn't have to use a tangent or a cosine button or any of those buttons. When it says exact values, I don't want a decimal. I want what you see here. So if it ends up being a square root or it ends up being a funky fraction, just leave it. That's your answer. So here is one where we're finally going to possibly need to use a calculator. So let's take a look at example 3. It says find the value of x rounded to the nearest tenth if necessary. Do you see how the other one said exact value and this says round to something? That's a really good indication that a calculator is involved. Okay. Now, I am going to still label stuff. So this is our theta. That's the angle we're looking at, 35. Attached to it is the adjacent. This is our hypotenuse. Now, if they said for me to find all 7 trig functions, I would have to find the missing side. But they didn't ask that. They just said find x. Okay. Which one of our trig functions from SOHCAHTOA uses adjacent and hypotenuse? Which one of those uses A and H, adjacent and hypotenuse? The cosine. Let's write that down. I know the cosine of theta is adjacent over hypotenuse. And let's fill in what we know. The cosine of 35 degrees is equal to adjacent over hypotenuse. We have an equation. The cosine of 35 degrees is what your calculator can do if it's in degree mode. So in like my red calculators on the back, if you look at the calculator on the front wall, right now that RAD is indicating it's in radian mode. You want your calculator to be in degree mode, and that's what that DRG button will do. There's 3 ways to measure angles: degrees, radians, and gradians. We're only going to use degrees and radians. Make sure it says DEG. So if our calculator is on, it says radian or degree mode, and I can show you how to change it if yours isn't in degree mode. Our final answer, we want to round to the nearest tenth. So when we're doing this, let's take the decimal out a few places. The cosine of 35, let's take it out 4 decimal places, is 0.8192. So all you're going to do in your calculator, you're going to hit the cosine button, then you're going to put in 35, you're going to hit equals. Make sure that your calculator is in degree mode. So that's a good way to check right now. Make sure it's 0.8192. Even a scientific calculator on your phone, on an iPhone, if you turn your calculator into landscape mode, there is a button for degrees and radians. Make sure you're on degree mode. Okay. Now, if I said something equals x over 7, how could you solve for x? What do you got to do to solve for the x? We got to multiply. We're dividing by 7, just like any other math equation. We're going to multiply both sides by 7. So if we multiply that by 7, and now your final answer is the one I want you to round to the nearest tenth, whatever the instructions say, it would be 5.7. Now, your hypotenuse should always be the longest side. So if you got a number more than 7, you know you did something wrong. Because we got 5.7, which is smaller than my hypotenuse, in my brain, that's a really good, just quick little check. I probably am on the right track. Okay. The smallest side should always be across from the smallest angle. The largest side should always be across from the largest angle, and medium angle, medium side sort of thing. So that's just a really good check. Any questions about example 3? Let's do another one like that. So for this one, it says find the value of x, round to the nearest tenth if necessary. So again, here's our theta, 41. There's our theta, 41. This is the side across from it, so let's label that as our opposite. This is across from the 90, our longest side that connects the L. That's always our hypotenuse. So if we are doing SOHCAHTOA, sine, cosine, or tangent, which one uses opposite and hypotenuse? Which one uses opposite and hypotenuse? The sine does. So the sine of theta is opposite over hypotenuse. So write that equation down, and then let's go ahead and plop into that equation what we're looking for. So the sine of 41 is opposite over hypotenuse. Okay. Now, the sine of 41, if we put it into our calculator, make sure it's in degree mode, let's take it out 4 or 5 decimal places. That's 0.6561. Now, in the last problem, it was not equal to 7 over x, it was equal to x over 7. And we multiplied both sides by 7. Whatever ends up in the denominator is what you need to cross multiply by. You always multiply by whatever ends up in the denominator. So that needs to multiply over there. So that equation is really going to turn into 0.6561x equals 7. Whatever is in the denominator cross multiplies. And then how do we solve for x? What do we got to do? What do we end up dividing by after all? Yes. Yeah, we end up dividing by that funky decimal. So x is just going to be 7 divided by 0.6561. Here's where you finally want to round to the nearest tenth. 7 divided by 0.6561 is 10.7 when rounded to the nearest tenth. Is it the biggest side? Because we were looking for the hypotenuse. So far, yeah, that's the biggest side. That's a really good indication that we got the right answer. 10.7 is the hypotenuse. It's bigger than the side we had. Yeah, we're probably good to go. So watch and be careful. Whatever ends up in our denominator crosses over. If that's the number, then it multiplies and crosses over. If it's an x, it multiplies and crosses over. Doesn't matter. It's always the thing that moves. Okay? Any questions about that one? Okay. The next few problems, we're going to hold off and talk about those tomorrow. But let's go start looking at the 7-1 homework. See the homework down here? Right now, you are prepared to do all of those except the word problems. Okay? So tomorrow, we're going to dive a little deeper into some word problems and applications of this stuff. For the remainder of the period, I want you to start your homework, and the ones with the green box around them, those ones are the ones that you're ready to go. You know how to do those if you follow my example. What's nice about these particular sets of notes, see where it says example 1 in that little orange font? If you look at any of my examples that say example 1, they're going to kind of go together. And then see this one says example 2, just find my example. That's why they have sometimes multiple things that say example 1, because they might give you multiple kind of versions of the same type of problem. See example 3. So, use that as your guide as you go through the problem. So for the remainder of class, could you please work on your 7-1 homework? Don't forget there is an Alex due Sunday. There is an Achieve due at the end of January. So make sure you get those done. There you go.